This is lesson 3-9, solutions for equations and inequalities. Our central question, how can you find whether a value is a solution to an equation or inequality? Pause to copy that down. We have one vocab word, a mathematical sentence that contains, and I want you to copy down these four symbols and also what each of the four symbols means. And you can draw it out the way I have it, or if you want to write it a different way, that's fine. So we have the greater than symbol, less than. This symbol means greater than or equal to. So if it has a line underneath of it, that means that it could be greater than or it could be equal to. And then the last one is less than or equal to. So copy that down, please. Okay, example number 1. What values make the inequality true? We have p plus 2 7/10 is greater than 4. And these are the values that we have for p. We have 1, 2, 3, and 4. So we're trying to figure out which of those numbers, 1, 2, 3, and 4, could go in place of p to make this true. So the way to figure that out is just to plug it in. So we're going to start with the number 1 in place of p. So we would have 1 plus 2 7/10 is greater than 4. 1 plus 2 7/10, if I do 1 plus 2 7/10, 1 doesn't have a decimal, so I have to add a decimal and annex a 0, so I can line them up. 0 plus 7 is 7, bring down my decimal. 1 plus 2 is 3. So that would give me 3 7/10. So now we have to just say to ourselves, is that true? 3 7/10 is greater than 4. Remember that the greater side is the bigger side. And no, that's not true. So 1 cannot be an answer. Now we move on to number 2. And we just plug that in again in place of p. Now we have 2 plus 2 7/10 is greater than 4. Go ahead and add this up. 2 plus 2 7/10. You have to add a decimal and a 0 to 2. Bring your decimal down, add them up, and we get 4 7/10. Now we can say to ourselves, is that true? 4 7/10 is greater than 4, and yes, it's true. So 2 is a solution. Now I could do 3 and 4 and plug them into p if I wasn't sure. But since I'm adding here, and I already know when I added 2 it was bigger, if I add 3, it's definitely going to be bigger. And if I add 4, it's definitely going to be bigger. So both of these are also going to be greater than 4 when I add them to 2 7/10. So my answer would be 2, 3, and 4, because those are the numbers that make this inequality true. Number 2, which values make this equation true? Now this is an equation because it has an equal sign, not a greater than, less than sign. So it's an equation. So again, we can just plug in these numbers for C. So we would have 13 4/10 equals 17 minus 3 4/10. So let's see what 17 minus 3 4/10 is. Now 17 is a whole number, so I have to add a decimal, annex a 0, and now I can subtract. Okay, the 0 becomes a 10, and 7 becomes a 6. Bring your decimal down, and subtract. So our answer should be 13 and 6/10, because when we did 17 minus 3 and 4/10, we got 13 and 6/10. So C has to be equal to 13 and 6/10. This is not equal, so that can't be it. 14 and 6/10 is not equal. 15 and 6/10 is not equal. So we have none that are equal. So we write no solution. That means that none of our answers, none of those choices for C would make our equation true. Example number 3, we have C plus 4 equals 8, and we have 1, 2, 3, and 4 that we can plug in for C. So this one should be an easy one, but we'll just go ahead and do it. We have 1 plus 4 equals 8, and we know 1 plus 4 is 5 plus 8. So that's not, or I'm sorry, 5 equals 8. And that's not true. Then we can plug in a 2. 2 plus 4 equals 8. We know 2 plus 4 is 6. 6 does not equal 8, so that's not it. Then we have 3 plus 4 equals 8. 3 plus 4 is 7. And 7 does not equal 8. And our last one, 4 plus 4 equals 8. We know 4 plus 4 is 8. So that is true. 8 equals 8. So our answer would be 4, because that is the only value that makes the equation true. Our last example, 15 is greater than or equal to r minus 7 and 1/10. And we have 10, 15, and 20 for r. So we'll go ahead and start plugging those in. We have 15 greater than or equal to 10 minus 7 and 1/10. So let's go ahead and subtract 10 minus 7 and 1/10. 10 doesn't have a decimal, so we have to add a decimal and a 0. So that becomes 10, 9, and 0. Bring our decimal down and subtract. We get 2 and 9/10. So let's see if that's true. We would have 15 is greater than or equal to 2 and 9/10. And yes, that's true. 15 is greater than 2 and 9/10. So 10 is an answer. So now we can move on and do 15. We would have 15 greater than or equal to 15 minus 7 and 1/10. All I did was plug in the number 15 where the r was. And over here I'm going to do my work. 15, have to add a decimal and a 0. And I'm going to subtract 7 and 1/10. And we get 7 and 9/10. So let's see if that's true. 15 is greater than or equal to 7 and 9/10. Yes, that's true. It is greater. And our last one, we have 20. So I'm still using this original problem, and I'm just plugging in 20 in place of r. So 15 is greater than or equal to 20 minus 7 and 1/10. And I'm going to do the work all the way at the top because that's where I have some blank space. So 20, have to add a 0. and I get 12 and 9/10. And then let's just see if that's true. We would have 15 is greater than or equal to 12 and 9/10. And yes, 15 is greater than 12 and 9/10. So all three of those are solutions, 10, 15, and 20. Okay, you have two practice problems. You're doing the same thing. Plug in those numbers in place of the variable and see if it makes it true. If it makes it true, then it is a value that makes the inequality or equation true. If not, it is not a solution. Don't forget your word problem or question and rate your understanding.